Okay, so we're going to talk about solving ax squared plus bx plus c equals 0 equations. So the first thing we need to talk about is in order to do this, we need to find two integers, which we're going to call m and p, with a sum of b and a product of a times c. Then we're going to write ax squared plus bx plus c as ax plus mx plus px plus c and factor by grouping. So the first thing we're going to do is an equation that has a positive b. So if we have 7x squared plus 29x plus 4, we're looking for two numbers with a sum of 29 and a product of 7 times 4, or 28. Because there's only two factors that add up to 29, we're going to go with that also equal 7 times 4, which is 28, which is 1 and 28. So we're going to take 1 and 28 and rewrite it. So now we have 7x squared plus 1x plus 28x plus 4. 7x squared plus 1x plus 28x plus 4. I'm going to pull out an x, and that's going to leave us 7x plus 1. And we're going to pull out a 4. And that's going to leave us with 7x plus 1. So now we have x plus 4 and 7x plus 1. Next, we're going to look at a negative b. So we need two factors that when we multiply them together, it's 3 times 20, which is 60. And the sum, so when we add them together, is negative 17. We can look at numbers like negative 2 and negative 30, negative 3 and negative 20, negative 4, negative 15, negative 5, negative 12. All right, so negative 5 and negative 12 are factors of 60, and then when we add them together, we get negative 17. So let's go with that. So we're going to go with 3x squared minus 12x and negative 5x plus 20. So we're going to pull out 3x from this first one and leave us with x minus 4 plus, we're going to go with negative 5x minus 4. Now we have 3x minus 5 and x minus 4. So that's how we can do a negative b. So again, two numbers that when we multiply them together, we get a times b, which is 60. And when we add them together, we get negative 17. Next, we're going to talk about what it would take to make a prime polynomial. So if a polynomial cannot be factored using integers, then we just write prime. So this one, we're looking for a number that when we multiply 4 and 5 together, we get 20. So two factors that when we multiply them together, we get positive 20. And when we add them together, we get negative 3. So for 20, we can do negative 20 times negative 1, but that doesn't work. Negative 4, negative 5, that doesn't work. Negative 2 and negative 10. But none of those, when we add them together, do we get negative 3. Because no factors with a sum of negative 3, then the quadratic expression cannot be factored using integers, so therefore all we do is write prime. Lastly, we're going to talk a little bit about how we can do this by factoring. So if we do this by factoring, then we need to set it equal to 0. So the first thing we need to do is subtract 3 and get that equal to 0. So we're going to have negative 16x squared plus 19x minus 3. So now, what can we multiply by so we can factor? Easy off the top of your head? No, not super easy? All right, so let's split it to what? What can we add? We got 16, negative 16 times negative 3. When we add them together, we get 19. Okay, we're going to go with 16x minus 3 and x minus 1. 16x squared minus 3x minus 16x plus 3. Right? So we multiplied by -1. We changed all of our signs. Okay, so when we do that, now we are solving for using the zero product property to solve to get zeros. So this one is going to be 3 over 16. And this one is going to be positive 1. So you can see there that we didn't necessarily have an answer, but if we multiply all of the sides by -1 to change all of our signs here, then we can use this to factor. So that's a way to solve all of our equations that are ax squared plus bx plus c equals 0.